What's up guys, it's Sean here. Welcome back to another episode of The Computer Scientist. Today we will be investigating a technique called experience replay to help us speed up the training of our QLearning agent from the previous video. So looking at the training code from last video, at each step we are calling the train method with the single tuple of step values which we use to run the optimizer. But essentially we are only using each experience tuple once, and then we forget about it when we get the next step's experience. So then the drawback of training with single experience tuples as we come across them is that this creates a bias towards training on common experiences that we see, which might starve out the training on rare experience tuples, which can be more important. But then what if we stored each step's experience and sampled the number of experiences to train on them at once? Then this would give the rare experience tuples more chance of being trained on in case we don't see them for a while. This is essentially what experience replay is about. So let's say we have a buffer of a fixed length. Then at each time step, we add the experience tuple we just saw to the end of the buffer. Then we can train on a batch of experiences by sampling these at random from the buffer. And when the buffer gets full, we would push out the oldest experience to make room for adding a new experience. So let's adapt this into our agent. For the buffer, we're going to use a DQ from the collections library. A DQ is essentially like a list where you can specify a max length, which will cause it to push items out the other side if we add new items when the max length is reached. Then in the train method, we would append each new experience to the replay buffer. Then to get our batch, we simply specify the batch size, then use the random choices method to sample k equals batch size items with replacement. Then we want to separate out the lists of each of the 5 experience values from the list of tuples in the sample. So we can do this using the zip function and passing in the individual tuples, which we can get using the star operator. Then we convert the tuples from the zip function into lists. We'll also have the current timed experience to make sure it gets trained on at least once. Finally, now that we have multiple experiences to train on, we need to specify the max function to take the max over the columns axis. We also need to set the shape value in our placeholders to none to accept any batch size. Okay, now we're ready to run this. We can see that a lot more weights are being updated now because we are training on batches instead of a single experience tuple. So coming to the end of the first round of training, we can see that we're reaching the goal a lot more often now because the rare experiences of reaching the goal are being trained on more often. Let's run it again to see how we do in the second round. Okay, so we can notice a lot of jumping around where we seem to be reaching the goal a few times, but then for some reason the policy is unlearning itself because of so many samples that we're training on. So this kind of behavior is probably because the learning rate is too high, which causes the updates to overshoot the optimal targets. So let's try reducing the learning rate and training this again. So now coming to the end of this first round, we can see that we're reaching the goal a lot more often than before because our learning rate is closer to what is required for reaching the optimal targets. So in the second run, we can observe that our model is learning the optimal policy in a lot more stable way rather than unlearning it at some point. So that's experience replay as one way to speed up the training efficiency of QLearning using a neural network. In the next videos, we will look at solving some of the more complex environments in OpenAI Gym with QLearning and neural networks. Anyways, thanks so much for watching this video. Be sure to give it a thumbs up if you found it helpful, and I'll see you next time. Bye!